Okay. Hello, everyone. Good evening. My name is Paul Markov. Welcome to the Toronto Centre RASC Recreational Astronomy Night meeting for September. I'll be your host for this evening, as I've done in the past, but thank you very much to Tom Luton, who filled in for me last month in August, as I couldn't make it. And also, hello to our viewers on YouTube. We have a pretty good, a very good lineup of speakers tonight, and we are going to start with Denis Gray first. He'll present the Celestron NexYZ smartphone to eyepiece adapter. That's because Denis has to slip out of here a little bit earlier tonight. And then we'll go back to the sky this month, presented by Chris Vaughan tonight. And finally, we'll have Michael Watson, who will present to us about a return to the southern skies in the land down under. And that'll wrap it up. We'll have our president take care of the announcements. And I would like to remind our speakers to please refrain from using too many acronyms. If you do, please explain what they mean. And show of hands, who is here for the first time, new member or not? Show of hands. Very good. Thank you for joining us tonight. And I think Denis is ready to go here. Come on down.
Okay, a little sound check. I'll get a thumbs up from sound guy. Okay, he's not giving me thumbs up. Excellent. All right, well, thank you very much, Paul. And thanks again for continuing to host these meetings. I think we forget sometimes how many years has it been. I think it's over 20. 2001. So coming up on 20 years hosting the Sky this month. I think he's been doing a great job. 20 more, Paul, 20 more. That may not be your goal, but we think it's a great idea. So I'm here to talk about a smartphone adapter. So I think some people know exactly what we're... Whoops, that's the pointing thing. There we go. Forward thing. So I'm just going to talk a little bit about what a smartphone adapter is and why you might want one. And I'm going to compare the two, the Ioptron option, which is the one I had before this one, and then we'll talk about the Celestron NexYZ adapter, and then a little Q&A to follow up on that. So this is really a kind of a mini product review, if you will, as opposed to a more comprehensive presentation tonight. So the basics of what is a smartphone adapter and why might you want to use one, it's essentially to help you with afocal photography. So in an afocal system, what you're doing is you already have some kind of an optical system, a telescope or a microscope or whatever it is, and that optical system is using a Mark I eyeball as its imaging device, if you will. So that eyeball is being put up to an eyepiece, and you're focusing it so that you're directly receiving the photons in your brain. So the idea with one of these is that you're actually putting a camera in place of the eyepiece. So the eyepiece is here, right about here is the focal place where the eye would normally go, and instead we replace the eye with a camera. And that's how you get a straightforward, simple picture there. And you know, the camera itself is kind of taking what it's given, and so it's the eyepiece, the optical system here, that's controlling what magnification you might get as part of that process. If you look at how this kind of photography is done, essentially the key success factor, if you will, is to have a nice steady mount, because generally when we're taking astronomical pictures, things tend to be dim, they tend to be far away and so on. So it's really important to have a nice steady mount. And this is kind of a classic system that you might use where you have some kind of a mechanical device, and it allows you to position your camera in an exact location above an eyepiece that's attached to a telescope. And so you're accurately lining up that camera lens with the eyepiece. Obviously, the better the optical system, the better the picture is going to be, and it works really well on bright objects because usually cameras are taking shorter pictures, but you can, with a system like this with a DSLR, you could actually go 10, 20, 30 seconds and maybe get a more dim object in your picture if you wish. So most people these days, or at least the average person, is not thinking, when they think camera, they don't think one of these anymore. They're thinking a smartphone of some kind. And they're really everywhere. How many people here tonight did not bring their smartphone? How many? 1, 2, 3, 4. All right, the rest of you all have smartphones. They're pretty well everywhere. Now, most of us are familiar with using them, familiar with taking selfies and other quick shots with them and so on. The lenses are awfully small, but the actual camera itself has got really, especially on the newer phones, it's got really good resolution, generally speaking. And they're coming in larger sizes now, so you're getting bigger pictures. You're able to check your focus more easily. And this is sort of to my overall theme here. They're the most likely kind of camera that you're going to find at a star party. In fact, I would challenge you to think, when was the last time you had a person come up to you at a star party with a DSLR in their back pocket? So that's not exactly what's going to happen. But if somebody wants to take a photo through your telescope, it's going to be with one of these. And I think that's really the biggest reason to have it. When I look at my sort of photographic equipment and my telescope inventory and so on, if I want to get the best possible picture, I'm not necessarily going to use a smartphone. But if I'm doing public outreach and I want to send someone home with a nice souvenir, then the smartphone is definitely the way to go. And it's not that bad. This is a comparison of 2 pictures of the full moon taken from the internet. So this one's a DSLR standard with a 400 speed ISO, just taking an automatic photograph, and this is an iPhone taking an automatic photograph. So when I look at the 2 moons there, I see both of them have a little bit of diffraction. There's a little bit of red at the top, a little bit of blue at the bottom. I'm able to see detail on one. One's a little more washed out than the other. You could fix both of those up maybe a little bit more, but overall, that's not a bad result. If what you want to do is just say, hey, I saw the moon tonight and it was pretty cool. That's really what you're looking for. So the key considerations if you're trying to use a smartphone, and I think Chris, when I was researching this, I came across your website. Chris knows all about how to do this the best, so talk to him afterwards. But essentially, one of the issues, especially with the full moon, is reducing glare. So you get a washed out photo, so you need to give yourself some tools perhaps to reduce that glare. A variable polarizing filter on the eyepiece would help with that. But a lot of the newer phones have both better cameras and optional software apps that allow you to take better pictures. And the key is what they call high dynamic range mode, where the phone will take an extremely bright object and an extremely black background, which is kind of what you see with the full moon, and it'll squeeze that high dynamic range down into something that the camera can deal with better, and you'll end up seeing more detail on the moon. You'll see a better result. And the other thing that I've noticed on my camera particularly is the ability to tap the camera for focus, and then I get that specific area focused in on, and then that tends to reduce the glare as well. So I get a better picture if I tell the camera, this is what I'm trying to take a picture of, particularly with brighter things. So it's one of those things that, if you're trying to do this on your own, the better you know your camera, the better your results are going to be. But when you're trying to do this in a public engagement sort of opportunity, then you have to think about, well, some people are going to be unsuccessful because they just don't know their camera that well. And if you know their particular camera model, you can help them out. But if not, just continue to drive on. So we're going to talk about 2 mechanical adapters tonight. The one on the left is one from Eyepiece that's been around for a little bit longer. And the one on the right is the NexYZ from Celestron, which is the one that I'm going to be focusing on a little bit more tonight. Just to sort of recap the Eyepiece model, essentially this is made up of a couple of mechanical pieces. We've got here the eyepiece itself, which comes with this package. So this is an eyepiece that's presumably optimized for smartphone cameras in some way. The eyepiece goes in here, and then this mechanical adapter grips the camera and then positions the eyepiece over the camera on your phone. So this is an example of how you would set this up. So first you would clamp the smartphone onto the back here. Then you would position the eyepiece over your camera lens, and then you tighten the whole thing up with this thumb screw here, which clamps both the width of the thing that's holding the smartphone, as well as locking the position of this arm, which controls where the camera is going to go. And that's how it would look when it's deployed on the telescope there. I hope that all makes sense to everybody. Now, I do have an example of this adapter up here. So after the meeting, people will be welcome to have a look at that and get a feeling for how it looks and how it works. So the one thing I found about this is this works really well if you've got the time to sort of be finicky with it, because the fine adjustment part is you have to loosen off that thumb screw at the back, and then the whole thing becomes loose, and then you have to adjust it, and then you have to try and tighten it up again and get it, and you're moving it in 360 degrees of motion, because the camera can move in any which way as you're going along. We have some people with very large phones that doesn't quite work with the maximum width of the adapter, so it doesn't actually work for the really big ones. And what I found was that, and that's sort of the reason when I bought the NexYZ, was I was up at the CAO in, I think it was May or July. Anyway, I was acting as a supervisor, and I was helping somebody to try and get a camera picture on our main telescope there. So it was like I had one person with me, one camera, and I said, great, we have this adapter, we have this Ioptron adapter at the CAO, and I said, great, I'll get that adapter and we'll get a nice picture of the moon for you. And that was it was a terrifically frustrating experience. We could not get it to line up properly, even though I was working with a perfectly well-balanced, high-end telescope with robust optics and everything else like that. I found it was very frustrating to get it lined up properly and in a way that the person who was going to take that picture was going to enjoy. So we ended up getting a couple of so-so pictures, a little bit, but that person didn't walk away with a good experience, which set me up for wandering into KW telescope and seeing a bunch of these on the counter. And I thought, this is interesting. So I asked the person for a demonstration, and I realized that this actually addressed a lot of the issues that I was having with the Ioptron model, and did it in a kind of compelling kind of way. And I thought that was an example of a better mousetrap. The other thing that's interesting about it is the price points are really almost exactly the same. So both of these are under $100, sort of $75 to $85, depending on where you buy them and what currency you're paying. But overall, this is about the same amount of money. So the first thing that this has is it has a vertical axis adjustment on it. I'll just go grab it here so we can show that for the audience, so that you can work to get your camera up and down closer. See that? Goes up, comes down. So I can get my camera lens the optimal distance away from the eyepiece. So when I'm doing that adjustment, what I'm actually doing is I'm sort of expanding or contracting my field of view on the phone, so I'm seeing more or less of what my target is. So that's kind of a nice feature. That's the vertical adjustment. The other adjustments are down here, and this is the ones that you would use most of the time, in the sense that this allows you to do horizontal and vertical adjustments to position that camera in exactly the right spot. So you're actually able to, start by putting the phone on this adjustment, get your height roughly the way you want it, and then the final adjustment is just going to be to get that camera lens in exactly the right spot there. And the degrees of adjustment is very fine. So I find that I'm able to precisely put it in exactly where I want to do it. There's an eyepiece clamp here, which you can see in operation. So this is designed to handle both 1 1/4 and 2-inch eyepieces, so it can be quite large and quite small. And the phone cradle is essentially, it's a spring-loaded option here, so I can just whip the phone out like that, and then put the next phone in, and do some adjustments, and say, okay, take a picture. So that's, again, thinking public ed, that's exactly the experience I want to have, that I'm not fumbling around or dropping somebody's phone in the dark, that I want to present this appearance that I actually know what I'm doing, and I'm actually somebody who's competent to handle somebody else's phone. And then the other thing that's nice about this is there's an actual, what I call a clamp lock. So you put the clamp on and it's loose, but then there's another adjustment here that allows you to tighten that clamp so that this whole unit here is firmly attached to your telescope, finder scope, or binoculars. So I've seen this on the web where people have actually put this on one side of a binocular to get a nice wide field of view and take pictures with that in that way. So the whole unit has been nicely engineered and nicely designed for its purpose. It's kind of cool. So just in terms of the way I see this, it's one of the things that's nice, and especially compared to the Ioptron, is this is one piece. The Ioptron has 3 different pieces that you have to put together in the right way and tighten in exactly the right way for it to work. The 3 axes of adjustment, which is where the X, Y, Z comes from, the left, right, and vertical, it's nicely built in. It's a good design. It really is nice and tight on the scope. So I'm actually, I can shake this a little bit, and I'm really limited by how tightly my eyepiece is attached to the scope here, not by anything else. So it allows me to have a bit of confidence that when I'm doing public outreach and so on, that this is not going to drop either their phone or my eyepiece. Specs say it goes 30 to 60 millimeters in diameter, and it should work on everything. There's adapters that come with the package that allow you to put this on microscopes as well. So if you wanted to take pictures of microscopy as well, that's an option. So obviously that's not something that we're doing, but that's something that some people might want. So the one thing I would say is a bit of a drawback is it is a bit heavy. So when I compare it particularly with the Ioptron, which is a very lightweight piece of gear, this is a bit heavier. It does need a strong mount connection. So this eyepiece really needs to be firmly attached if this is going to work well and not slip, but that's something that's easy to do. I really like how easy it is to make the fine adjustments. I was just trying it out in the parking lot, got some very nice pictures with it, and I think that the other thing that you could do with this is if you are doing this in public ed and you wanted to be multitasking, I can leave the eyepiece on, swap an actual eyepiece in and say, would you like to have a look for yourself? Okay, let's put this back and we'll put a camera on. So I'm able to do that kind of a scenario. And if I have a matching pair of eyepieces, I could actually not even worry about the focus on the scope. So I'm hoping that all of this put together is going to lead to a really nice experience my next few star parties, and hopefully I can be the guy who will be there to allow people to shoot the moon. So there we go. So that's my story. Now, John Bodanovich has graciously volunteered to be the keeper of this kit here. And so John's going to allow people after the meeting, if you want to go out in the parking lot and muck around with this and try it out, then he will relay it back to me afterwards. So John, thank you very much for helping with that. And I'll just throw it open to see if there's any questions at this point. Yeah.
Thanks, Dad. Sounds great. I can't wait to get my hands on one of those. It's also great if you want to show a group what the telescope's looking at. Mm-hmm. So you can actually, I know a lot of people want to put their eye to the eyepiece, but it's also one way that a group could see an event, say an occultation or something where the star's going to wink out or reappear.
Put it on video mode.
Everybody can have a look, and you could video it at the same time. You could record it.
Nice idea, yeah.
How well do the 3 fine adjustments lock, or is there a way to lock them in place?
They don't actually lock. They do tend to be, there's a certain amount of stiction there. So they're not, they don't tend to move, and when you do move them, it takes a deliberate movement to move them, but I don't see any option to tighten anything up there. I think it's something that's just designed to sort of work in a specific way. It's rack and pinion sort of gears that are driving this mechanism, and that might be a weak point, but I don't see anything right now that causes any worries. Part of it too is that if you're on a telescope, you're going to be sort of in a resting position like that, so you should hopefully not be putting a lot of force in any one direction that would cause it to migrate by itself. Yeah.
We have a question from online. Peter asked if you've tried the Carson hookups 2.0.
The Carson hookups? No, I haven't heard of that particular model.
Okay.
Sorry.
Further to that, he mentioned that it was highly recommended on Amazon, but unfortunately didn't work too well with his larger iPhone 8.
Well, I think this, I've seen online reviews of this and videos with an iPhone 6, so I don't know what the scale up between the 6 and the 8 is, but certainly I have seen it used successfully with some iPhones, and so I would suggest that perhaps if, like what I noticed when I was researching this talk is there's a lot of people that have their own reviews and things online, so if you want to research a specific phone combination, you can probably find somebody who's tried it and would give you some specific feedback to our viewer out there. Michael.
Yeah, so Denis, I've got to imagine that the vast majority of people who are going to do this are going to be shooting the moon, rather than other objects, even bright planets, because they're so very small in most telescopes. And so, you know, obviously the telescope is going to be, you know, aimed up, and you're probably going to be using then a star diagonal, right, as opposed to having to look up. That being the case, your users who may not be familiar with astronomy are going to have flipped images of the moon, right?
Right.
And they're going to have to be told that and understand that. Just something that I think a
So
lot
I have
of
to explain the mirror, the whole mirror flip thing,
yeah,
three or four
entire thing
reflections.
is flipped.
Yeah.
Yeah.
I could see that. I think most people are just happy to see some craters. I think that's generally what that's what I've been finding is it's like, wow, I got craters. Look, I got craters. But you're right. The ones that are paying attention are going to go, the moon's that way and the moon's this way. What's that all about? So yeah, we'll see. I'm anxious to sort of see how it goes. I'll have my first star party opportunity on Saturday, so I'll see how it goes, and I'll let you know the next time I'm here. Yes, sir.
So other people want to take a look. There's another example. I've set it up on an 1.25" eyepiece.
Okay.
I do have a 2-inch eyepiece with me that if you want to see it put on a 2-inch eyepiece, you can do that too.
Yeah. And what's been your experience with it so far?
The problem that I've had was that the clamp on an 1.25" eyepiece, it has to be held square in order to see through it. And my first experience was I had an eyepiece that had a rubber ring.
Okay.
And unfortunately, I couldn't get it in the dark square enough. I could play around with it at dusk, but not at night. What I have found is if you put, you know, a little rubber shim or foam or other things on it, you can do that. But trying to do this, learning how to do this in the dark is not a successful experience for me.
I think that's a general rule for almost every piece of astronomy equipment, but you're quite right.
Okay.
But I think that kind of comes back to what I was suggesting too, is that for public education, I think this combination with a specific eyepiece should be locked and loaded before my first guest arrives, and I shouldn't be mucking around with that and changing it up because I think that's sometimes how we fail is people say, "Oh, could you also look at Saturn too?" And it's like, "Oh, okay, sure, I can do that." And then what ends up happening is you end up losing a lot of time moving from one target to another, and then something goes wrong. And I'm planning to really stick with one thing on Saturday. I'm just going to be focusing on the moon, and I'm going to be offering pictures, and I'll see how that goes. But we'll see whether that works out or not. Yes, sir.
Pretty excited about everything that you're showing, especially this mount. My first experience with taking pictures of the moon with my cell phone was 2 years ago, when my sister had given me an 8x magnifier to attach to the cell phone. And then I put that in a Barlow. And then I put that in my mount, and I was able to get a perfect focus. So with moving the mount around with the remote, and taking a picture with a selfie stick, the Bluetooth part of the selfie stick, I was able to get perfect focus. And I wasn't able to get the whole moon. I would only get parts of the moon, which means I got the craters absolutely crisply and the shadows and everything. So that's the first point. Second point, part of the solar eclipse team in London. I'm part of the London Astronomical Society there too.
Oh, welcome. Yeah, welcome here.
Thanks, and I'm also a member here now.
Oh, great.
I've
okay.
moved here.
Okay.
And there were 7 or 8 of us with telescopes, and we had 7,000 people show up on the hill at the university.
Right.
So from 1 o'clock till 4 o'clock, at each telescope, we had a lineup of 250 to 300 people. And every one of them had a cell phone, and every one of them wanted to take a picture.
Yeah.
We were remarkably successful, even with just hand holding. You know,
Right.
if people would get embarrassed and would want to move away, I insisted that they stay there until they took a picture, because they'd been in the lineup for at least
Right.
45 minutes.
Sure,
right?
good, good.
So they all got good pictures. I had a Canon with an adapter, a 2-inch adapter, in the eyepiece holder, and I kept that on for the whole time. It seemed to show a much better picture through the eyepiece, when people looking through the eyepiece, than anything else I had. There was a guy there from the London Free Press who also had a Canon. So sure enough, I switched my camera out, switched his camera in, and he got some beautiful pictures that he published
Nice.
later
Okay.
on.
Yeah.
Another, I'm just mentioning this because there's other ways of doing this at star
Yeah.
parties.
Mhm.
People will come to you with SD cards.
Yes.
Well, you take the SD card out of your camera, you put that in their SD card in your camera, you shoot away, give them their SD card back. It works.
Yeah,
It
yeah.
just works, yeah.
Just requires a bit of preparation on the part of the person who's coming, but yeah, if you're able to do that, that's a great way to do it too.
Well,
Yeah.
I wasn't prepared for any of this, you know, any of this. I thought I'd have an eyepiece and people would be looking through an eyepiece.
Yeah.
But I ended up with the only time lapse, enough pictures to do the time lapse of the
Cool.
thing.
Nice. Well, that's a
There's
great
other
story.
ways of
Thank you
doing
for sharing.
things, yeah,
Thank-
but I'm going to get one of those. And
Well, now you can try before you buy, because we've got
I'm
two
in
of them.
Waterloo tomorrow.
Excellent. Okay.
Any more questions?
Going once. One more. Got a couple. Yes, sir.
You mentioned autofocus. You're pretty happy with that.
Yeah.
Do you use auto exposure too?
That's the part I'm not as familiar with my camera's controls, and I was sort of mentioning that everything I read online said if you can get the high dynamic range, if you can control your exposure, then you will get a better picture, because often the moon will get blown out kind of thing unless you filter it. And I know Chris has got more information on that, but it depends a lot on how old your camera is and what settings it has available, because each model kind of adds a few more options in terms of controls, and you know, being able to set like a shutter speed or an ISO value makes a huge difference in terms of what you're able to do. But I found, like in my camera's case, was blown out, but if I focused on that specific area and if I can make the picture of the moon fill most of the screen, then the automatic exposure adjustment will kick in, right? It's when you've got a lot of black and it's trying to balance things the way it likes to that you end up with things like Jupiter being blown out and so on. All right, well, thank you very much, everybody. I'm sorry I have to go, but hockey season is on again. So we'll see you in the spring, but hopefully before then. Thank you.
All right, here we go. Let's go through the sky this month. I'm covering the period from tonight until the next meeting, which is October 10th. So we're spanning the next 4 weeks. As usual, I'm going to talk a little bit about some space exploration news and updates. and then review some this month in history information. How's that sound? Testing, how's that sound? All right. Then we'll get into observing and cover sun and moon, planets and dwarf planets, what they're up to, talk about a comet that's obviously available right now, asteroids, satellite passes, occultations, and early fall targets to look at. And all of this will be uploaded to a document that I'm preparing and putting on the website at rascto.ca. So I'd like to acknowledge some of the pictures by members that I'll be using in this presentation, including Steve McKinney and Michael Watson and Lynn Hilborn. And this is one of Michael's Milky Way shots right here. So in case you're feeling drowsy and you want to fall asleep, here are some headlines just to sort of preview what I'm going to talk about. We have longer nights, obviously, at hand now. We're into aurora season, and I'll cover a bit more about that. We have Comet 21P Giacobini-Zinner doing a number of encounters because it's going to be actually flying down the Milky Way over the next month. Look out for zodiacal light over the next 2 weeks in the mornings. We have an asteroidal occultation on the 16th. We have the moon occulting a fairly bright star on the 21st. We have the equinox on the 22nd. We have an opportunity at a convenient time to watch Algol brighten from its minimum on the 30th. And then we have a number of ISS evening passes starting up in the next week or so. So in terms of space exploration, there's nothing too high profile or exciting in the next next month of launches, although I will mention that a couple of these launches are being done by India, which is great to see. They're coming along. We've also got supplies heading up to the ISS from Japan, and this is an interesting one. It's an air launch rocket where they drop the rocket out of an airplane and then it fires its engine and takes off. And a lot of these are actually Earth observation programs, ISAT-2, the ICON satellite, and Novosar's radar imaging and Earth observations. So good to know the other countries are doing their part. So here's an update on the Dawn space mission. So Dawn has sort of dropped out of the headlines, but it's nearing the end of its mission, and it's now because they've done all the science that they had planned to do. They're now able to take more risks with the spacecraft, and so they've been dropping the orbit down closer and closer and closer to the asteroid Ceres. And this is a high-res, close-up picture of a place called Cerealia Facula, and all those white spots that we saw on Ceres earlier on as it was approaching the asteroid are sodium carbonate deposits that have been brought up in brine. They think there's internal heating inside Ceres, and there's some means for liquids to sort of come to the surface and bring up these deposits from below. So the imagery in this picture has been taken from as low as 35 kilometers above the surface. And it's draped on a topographic model. So there's no vertical exaggeration on this picture. It's the actual how it would look. The spacecraft's about to exhaust its hydrazine attitude control supply. And once that happens, the mission will go dormant, and they'll just let the spacecraft orbit Ceres for decades. They don't want to risk contaminating the asteroid by crashing the spacecraft onto Ceres, so they put it into a protective orbit that they expect will last for at least a few decades. Maybe somebody, Elon Musk III, might go out and collect it at some point in the future. Who knows? The Hayabusa 2 spacecraft is now arrived at the asteroid Ryugu, and it's getting ready to do a sample return and bring that back to Earth. And this is a little diagram that shows shows that it's going to come in and touch down, grab a sample with its arm, and it's also going to deploy some little hopper probes. And they just have a mass inside them and an actuator that makes the mass flip up into the top of the satellite so that in the low gravity of the asteroid, it'll just drift up and then land somewhere else on the asteroid, and it can hop around using this little mass tossing technique. So this week, it's going to do a rehearsal for the actual sample grab, and I'm hoping I get these videos to play. No. I've had some videos that were in here that are not playing. But it's the touchdown, the sample return is due to happen in late October, and this week they're going to approach within 40 meters of the asteroid and just sort of practice, bring it up. And if you want to see some really wonderful 3D animations of the asteroid, you can go look up Roman Tkachenko, either on Twitter or on his Instagram page, and he's got some amazing 3D models that he's animated. The Juno spacecraft still doing its thing around Jupiter. It just did its Perijove pass number 15 a couple of days ago, and these are close-up images that have been prepared by Sean Doran, and he's got a website and a Flickr account that has loads and loads of these fantastic processed images that you can actually access and download yourself and play with if you like to. And a couple more things that we're just keeping an eye on. Of course, we've got the New Horizons spacecraft is less than 1 astronomical unit now away from its next target, which is the 2014 MU-69 Kuiper belt object nicknamed Ultima Thule, and that's going to happen on New Year's Day of 2019, so it's just a few months away. And then we've got OSIRIS-REx, which is another asteroid touch and return sample mission, and that's due to rendezvous with asteroid Bennu at the end of the year in December. So in terms of this month in history, we've got some astro birthdays. In 1764, we had John Goodricke. He was an English astronomer, and he researched periodic variable stars, including Algol, the eclipsing binary. I'll talk a little bit more about Algol a little bit later in the talk. In 1874, we have Gustav Holst, who composed the Planets Suite. And of course, Pluto hadn't been discovered at that point, so Pluto was not part of the Planets Suite. And then in 1918, we have the birthday of Sir Martin Ryle, who's a pioneer of radio interferometry. We're marking the passing of Edwin Hubble at the age of 63 in September 28th of 1953. And he of course, used the 100-inch Hooker telescope at Mount Wilson. That was the only telescope larger than the David Dunlap Observatory telescope when it opened, when that telescope opened in 1935. The 100-inch was the only one bigger on the planet. 1958, we have the birthday of Neil deGrasse Tyson, American astrophysicist and science popularizer. 1873, we have Hertzsprung, Einar Hertzsprung, the astronomer that worked with stellar classification and co-developed the famous Hertzsprung-Russell diagram of stellar evolution. And finally, in 1958, we have the birthday of John Grunsfeld, American physicist and astronaut. There you can see his day at the office. In 1965, Lost in Space premiered only weeks after Star Trek, but not everybody was happy about that. But the Lost in Space people, they didn't care. In 1959, we had Russia's Luna 3 take the first photographs of the moon's far side. And then in 1977, Voyager 1 imaged the Earth and Moon together for the first time. So there we have the Moon and Earth back in 1977. In 2003, the Galileo spacecraft was impacted into Jupiter to end its mission. There's a little cartoon showing some of the orbits that spacecraft did. And in 1846, we have Johann Galle discovering Neptune within 1 degree of the predicted position, and he confirmed it over the next couple of nights. He never took credit for that discovery, although he's the one that did. 1905, we have Einstein's E equals mc squared paper was published. All those soldiers paying tribute on the aircraft carrier there. And this is cool. In 1858, William Usherwood took the first ever photograph of a comet, Comet Donati. It was a 7-second exposure with a f2.4 portrait lens, but that photo has since been lost, unfortunately. So we have this artist rendition instead. And the following night, G.B. Bond at Harvard took the first comet images through a telescope. He took a number of exposures, actually took through a telescope. In 1923, Edwin Hubble identified the first ever extragalactic Cepheid variable star, designated V1, in Messier 31. There it is there. Right, that little spot, and here are a series of frames showing its variability over time. 1957, the Soviets put up Sputnik 1, first man-made object to orbit the Earth, and of course, in response, NASA was created a year later, and we're just celebrating NASA's 60th anniversary on October 1st. Also in 1995, the first exoplanet was discovered on October 6th, and it was in orbit around the naked eye star 51 Peg, which you can see on a dark night, sort of sitting here off the western side of the western edge of the Great Square of Pegasus. And they used the radial velocity method, where the planet was tugging on the star, and the radial velocity measurement could be graphed up, and you could see how the star was being yanked back and forth by the large planet. It's a hot Jupiter planet orbiting around that star. So in terms of star parties and opportunities for everyone to use their new smartphone holders, we've got a number of our RASC events over the next little while: Dark Skies, Millennium Square, City, and the Solar Observing. And I'm sure Ralph will recap those later. Also wanted to mention the Lennox and Addington stargazing events that happen on September 14th and 15th, and the Northern Lights Festival in Kluane on the 21st and 22nd. And there's also Frontenac stargazing in Ontario on October 6th. And I thought this was fun. I grabbed this map of the light pollution map for Southern Ontario and plotted stars on it where RASC members typically go observing. And so you can see, of course, we've got the Science Center and Bayview Village and the DDO embedded in the bright city lights. And then we've got Forks of the Credit to the northwest and York Soaring, which is in a bit of a better zone. And of course, the darker, or so the whiter the color, the bluer the color, the less light pollution there is in this map. In the northeast, we've got Glen Major Forest, and then about twice as far away is Long Sault. And you've got our CAO up here. It's just too bad the CAO wasn't maybe a little bit over here. It's a little bit better. Of course, Collingwood is starting to really bother the skies at CAO. And then here's where the North Frontenac and Lennox and Addington sites are, off to the east, Peterborough area, where the skies are darker. So observing, keep your eyes out for the zodiacal light. The zodiacal light is interplanetary dust particles in the plane of the solar system that are illuminated by reflected sunlight, and they sort of form a wedge parallel to the ecliptic, visible for the next couple of weeks in the morning sky. So rascals are invited to participate in mapping light pollution through the Globe at Night program. This month's focus is on Cygnus. And if you go to the globeatnight.org website, you can download sky charts, which you then take outside and try to determine which of these magnitude limits you can view from your observing location, and then report your findings. So here you've got the summer triangle stars around 2.5 mags, but then we get down to 4.5 mags. You can start picking up Deneb and the rest of Cygnus sort of running the wings this way, and Albireo sitting in the middle. So here's the website you can go to, globeatnight.org, and the observing period runs from the 1st to the 10th of October. So sunrise and sunset over the next period of a few weeks, we increase we shorten the number of the hours in the day from 12 hours and 40 minutes down to 11 hours and 17 minutes of daylight. We have the autumnal equinox for the northern hemisphere on the 22nd, and we can expect enhanced aurora during this time because when the Earth is tilted when the Earth's axis is tilted sideways with respect to the sun, the Earth's north polar magnetic field vector is diminished, and that allows more solar magnetism to invade our magnetic field. So that's why you get enhanced aurora near the two equinoxes. Astronomical twilight, the astro imager's friend. So the sky is not truly dark until the sun is 18 degrees below the horizon. You can see first we have civil twilight, then nautical, and astronomical twilight is the period between 12 and 18 degrees. As soon as the sun gets lower than 18 degrees and its sunlight is no longer able to scatter off the atmosphere or refract over the horizon, the sky becomes truly dark, and that's when you want to start taking your astro images. And so tonight, astronomical twilight ends around 9:11 p.m. We'll start at 5:14 tomorrow morning, and we're actually gaining about 3 minutes per day of night observing time. So we have about 8 hours of imaging time right now, and then a month from now, that increases to 9.5 hours of imaging time, if you don't mind the cold. It's going to get colder, but it's also going to get darker longer. And there's just a graph of the balance between the daytime and the nighttime through the course of the year, and here's the period of the next, from tonight's meeting to the next meeting. You can see that the nights are getting longer. In terms of moon phenomenon, we've got the first quarter moon on the 16th. We've got the full harvest moon happening on the 24th. It's the harvest moon this time because it's the full moon that occurs closest to the equinox, the fall equinox. Last quarter on the 2nd of October, and the new moon happens on October the 8th. And International Observe the Moon Night is on October 20th. Now, just to explain what's happening with the harvest moon and why it's so interesting and important, is that around the time of the autumn equinox, the ecliptic is highly tilted, it's very shallow with respect to the horizon. You can see here's the moon's orbit, roughly parallel to the ecliptic. And so what that means is that the moon rises at almost the same time for a series of nights around the full moon. It's only about 27 minutes difference on the nights on either side of the full moon. Whereas near the winter solstice, the moon is rising more than an hour later every night. So what this means is that around the harvest moon time, you can sort of go do your evening walk with the dog, and you can say, oh, there's the moon. And then the next night, almost around the same time, the moon's there again, and you sort of keep noticing it night after night because it's not changing very much. All right, so where are the planets up to these days? So right now, in the early evening, we've got, this is the sky for September 26th. We're going to have Mercury sort of hanging out near the sun and not visible. And we've got Venus setting in the early evening, followed not too long after by Jupiter. And then, of course, towards the time the sky gets nice and dark, we've got Saturn and Mars in the southern sky, and then we can start picking up Neptune. And if we wait till midnight, we've got Mars, we can pick up Neptune and Uranus nice and high over the southern horizon, sort of their optimal times when they're highest above the horizon. And you've got the asteroid Juno is available as well. So what's going on one by one? So Mercury is still observable with difficulty for the next few days. It's going to show a nearly full phase in your telescope. It will reach superior conjunction with the sun on the 21st, and after that it's going to join the morning sky for a poor apparition for the northern hemisphere. The ecliptic is too shallow, and Mercury will be sitting below that ecliptic, so it's not going to get very high above the horizon before the sun rises. Venus's long apparition is coming to an end. We've been happy to have it in our skies for months and months and months, but now it's rapidly dropping towards the sun, and by the end of September, we'll be pretty much done with Venus for this year. It's going to reach, though, its maximum brightness on the 21st of magnitude minus 4.78, so it's still not finished getting bright. Right now, it's waning in phase and growing in size because it's actually approaching the Earth and starting to move in between the Earth and the sun. And right now, it's setting about 8:30 p.m., and as I said, it has about magnitude 4.7 in it. It's showing about a 32% full illuminated phase in a telescope. Mars is going to remain visible in the southern and western sky after dusk for the next little while. It's in western Capricorn. It sets around 2 a.m. now, and it'll set by about 1:30 a.m. at our next meeting. You can look for the moon sitting about 4.5 degrees to the north of Mars on the 19th of September. And just for those sort of interested in what Mars is going to look like in your telescope over the next little while, so here's the graph. The yellow line is Mars's magnitude or its brightness, and the red line is the size of Mars's disk in your telescope, and the green bar here is where we are now. So you can see that both Mars's magnitude is decreasing, and so is its disk size, although it's shrinking in size faster than it's dimming. The slope of the disk size graph is steeper than the magnitude graph at this point. So we've really gone past the peak, the really good time now, but it's worth tracking down still for the next while as it slowly leave it in our dust. Jupiter, we're entering the closing days of our Jupiter observing for this year. It won't be back in the evening sky till about next May. Right now it's setting about 10 p.m., and by the time of our next meeting, it'll be setting around dusk, around 8:17 p.m. And you can look for the moon, the young crescent moon, sitting about 4 degrees to the northwest of Jupiter on the 13th. That's tomorrow night. Saturn, if you haven't noticed, Saturn has been hanging around near some really cool deep sky objects for the last while. It's sitting above Sagittarius, above the teapot of Sagittarius, right next to the Milky Way. And right about now, it's only a couple of degrees, or a half a degree, near the Trifid Nebula and the Lagoon Nebula. So wait for the moon to disappear and then have a look and see if you can see it there. Sets around 12:30 now and about 10:42 by the time of our next meeting. So the ice giant Uranus is an all-night target, rises after 9 p.m. It's moving retrograde in Aries. It's actually moving more or less directly towards the star Torcular or Omicron Piscium. So you can use that. That's a naked eye star. You can use that to sort of find it. And this is the track over the next month of what it will do. Likewise, here's the track of Neptune over the next month. Opposition was just last week, so it's an all-night target now. It's in Eastern Aquarius. It has a magnitude minus 7.8. And it's actually sitting midway between Phi Aquarii and this star Hydor. And you can sort of split the difference and find Neptune using those with binoculars or telescope as your guideposts. Now, in terms of looking at Algol is sort of a great beginner variable star observing technique for beginners. So Algol, of course, is sitting here in Perseus. It's in the northeastern sky, and it's an eclipsing binary system, which means it's got a main star, and then it's got a smaller star in orbit around it, and the orbit of the smaller star is essentially in the line of sight between us and the main star, so that every 2 days, 20 hours, and 49 minutes, the minor star passes in front of Algol, and it diminishes the brightness. So here's the observational light curve. So it basically maintains a magnitude of about 2.2 most of the time. And then for about 10 hours, every 2 days and 20 hours, it drops to magnitude 3.4. So if you want to, if you find the minimum of Algol, then all you need is 5 hours to watch it to return back to its full brightness. And it's a noticeable amount, a noticeable difference. So the Observer's Handbook lists these minima of Algol for you to notice. And I've just mentioned that on the 30th of September, there's one that starts at a relatively convenient time of 9:45. So if you wanted to start around then and look at Algol again after midnight, you should be able to notice that it's brightened considerably. So that's a way to get started on variable stars. In terms of what's happening in minor planets, another 1,170 minor planets near-Earth objects, those are the red dots, have been discovered since January 1st of this year. Another 5,000 minor planets. We're finding more and more of them all the time. And of course, we're interested in inventorying these objects in case we find any that might threaten the Earth in the future. And we've already found another 33 comets this year. So a rate of about 4 a month. Speaking of comets, so here's a great picture of comet 21P, Giacobini-Zinner. So 21P refers to the fact that it's the 21st periodically returning comet. It has a period, I think, of about 6.5 years. I can't remember the exact number right now. But it just reached perihelion and perigee, which is roughly happened around the same day on the September 10th, because its perihelion occurs at about the distance of Earth. So it was near Earth and nearest to the Sun around the same time. And here's a picture that was taken on September 9th showing Messier 38 and 36 and the Spider Nebula in Auriga as it passed through that constellation. And here's the light curve. So this is a little out of date, but we're sitting here in just past September 10th or so, and so we've reached a peak magnitude of about 7, and now it's going to slowly start declining again. But while it does that, it's going to do some cool things. So its orbit, this is the orbit over the next 4 weeks, from the top of the arrow to the bottom of the arrow. And it's going to basically fly right down the Milky Way, the winter Milky Way. So right now, it's in the northeastern sky. It doesn't rise till about 11:30 p.m., so you want to sort of stay up late. And it culminates after sunrise. So it just gets higher and higher and higher, and then the sun comes up and spoils the party. But here are some of the encounters that we're going to do over the next few months. So it's going to pass right through Messier 35 on the 15th. It's going to fly past the bright star Propus and the Jellyfish Nebula on 16th and 17th. It's going to pass near the Christmas tree / Cone Nebula on the 24th. And then it's going to sit really close to the Rosette Nebula on the 26th. That'll make a fantastic picture. And then if the brightness holds up for us, it's going to pass near Messier 50 on the 8th and right through the Seagull Nebula on October 10th. So there's some opportunities to try to look at the comet through the telescope or take some long exposure photographs to see if you can catch it with some of these deep sky objects in the Milky Way. Meteor showers, we just have one meteor shower starting up. That's the Orionids. Will start before the time of our next meeting, but it doesn't actually peak until about a month from now, and that's about a rate of about 10 or 20 meters per hour. Unfortunately, there'll be a nearly full moon for this year's Orionid, so it's not really something to worry about. And the radiance up between Gemini and Orion's cloud. In terms of satellite passes, right now we've got morning passes that are going to persist until about the 18th of September, and then we'll transition to evening passes on the 20th, and most of those will happen between 7:30 and 9:30 p.m. And here are some brighter ones. I've listed them in the handout that I've posted on the website. See, there's a really nice bright high one on the 10th of October. In terms of iridium flares, those are the glints of sunlight off the high passing iridium satellites. And these iridium flares are becoming on the verge of becoming extinct because these iridium satellites are being deorbited and taken off the system and replaced by ones that don't flare. Most of the current iridium flares are occurring now between 7:30 and 9 in the evening and 5:45 to 6:30 in the morning. And you can find out when they happen by going to heavensabove.com and entering your location. There are also smartphone apps that list them, and I do tabulate them in my weekly Skylights blog, that you can also refer to that as well. Occultations. So I picked out one good occultation that I noted for the month. On September 16th at about 5 in the morning, this fairly bright asteroid, 11.8, magnitude 11.8, called Sappho, which is in Taurus, is going to occult this star, magnitude 7.2 star, so that's pretty doable. Dipping 4.61 magnitudes for 5 seconds at an altitude of 69 degrees above the horizon. And you can see that the standard deviation for the predicted track, which is down the center here through Aurelia, anywhere between the blue lines, you're within 1 standard deviation of that. And of course, there's the CAO sitting right on that track. So if you want to head on up to Lake Simcoe or head over to the CAO to try to catch that, that would be a good one to try for. And then lunar occultation. So the moon on the 21st is going to start in daylight. So it'll cover the star Delta Capricornus in daylight. The star will disappear behind the dark limb of the moon. And then by 8:10 p.m., it'll be in a darkened sky. The star will reemerge from the bright western, eastern limb of the moon. And this is the sky shown at 8:10 p.m. I'm going to list some other multiple star occultations this month. So Mu Ceti, 16 Gem, New Gem, and Delta Cancri, those are all multiple double or triple stars. So it's really interesting to record the behavior of those as they get occulted by the moon. The AAVSO asks for data on those objects. So what do you want to look at for the next month? Well, you want to look at objects when they're highest in the sky, when they're crossing the meridian, and when they're through the minimum amount of atmosphere. So this big blue circle here is the boundary between lots of atmosphere when things are low and the minimum amount of atmosphere when things are high in the sky. It's called the amount of air masses. And so the constellations that are going to be on the meridian, some of them we have no choice about. They will never get this high, but you've got Corona Australis, Sagittarius, Scutum, and Serpens Cauda. And then constellations that get into the thinner atmosphere up above would be Aquila, Sagitta, Vulpecula, Cygnus, Lyra, Eastern Draco, and Cepheus. That would be at 9 p.m. Then by 11 p.m., we pick up Microscopium, Capricorn, Western Aquarius, Equuleus, and Delphinus, and the western part of Pegasus. And we got Cygnus, Lacerta, and Cepheus, and part of Draco again. And then at 1 a.m., stay up late, you've got Sculptor, Pisces Austrinus, Aquarius, the western part of Pisces. You've got Pegasus and the Andromeda, and Lacerta, Cassiopeia, and Cepheus. In terms of what you might want to look at, some of the all-stars, things you can just show people with their naked eyes, would include the teapot asterism and the summer triangle. If you've got binoculars, you can point out the coat hanger up inside the summer triangle, and the square of Pegasus. Globular clusters to look at would include M13 and M92 in Hercules. We've got M22 in Sagittarius, and M2 in Aquarius, and M15 in Pegasus. Early fall blobs in the sky, double cluster in Perseus, Andromeda Galaxy in Andromeda, the wild duck cluster M11 in Scutum, M33, which is dim, but you could try for it. And you've got the Heart and Soul nebulas in Cassiopeia, and the Veil in North American and Crescent nebulas in Cygnus. And in terms of sort of planetary nebulas, you've got the Ring, the dumbbell, the blinking planetary, the blue snovel, and the cat's eye. And don't forget the owl in Ursa Major. And double stars include Alberio, the double-double, Marfic in Hercules, and Almach. And it's fun to teach people the bright stars. So why not point out Antares, Vega, Altair, Deneb, Arcturus, and Capella. So hope to see everybody out at some of the observing sites at Long Sault and Bayview and the CAO and even DDO. And that's it for me. Thanks.
Hey, Chris, talking about Mercury, it's just finished morning apparition now, so it's going to be an evening apparition. I think you might have said morning apparition.
I may have had it backwards, sorry. Yeah.
Yeah, it's going to be
You're
in the
the
evening
expert, Ed.
somewhere. Thank you.
Chris, I have a question myself. What is the source of that light pollution map that you showed?
Oh, if you Google light pollution maps, there's someone has created this map. It's a Google map that you can zoom in and out of, and then it's got about 8 layers on it. So you can actually look at historical evolution of light pollution over time. I'll include the link in the notes. But yeah.
Any
Great.
more questions for Chris? No? Very good. Okay, thank you,
Thanks.
Chris. All right, thank you.
Society 48 years ago in 1970, and I've been a member continuously since then. And some of you will know, those of you who follow any of my astrophotography on my Flickr page will know that that's one of my main interests now, as well as solar eclipses. So I think it's fair to say that every observational astronomer who lives in the northern hemisphere wants to get into the southern hemisphere at some time in her or his life, and in my case, as many times as possible, because there's just so much great stuff down there. And for northern hemisphere astronomers, particularly observers who are interested in the Milky Way and the center of the Milky Way, it is just so tantalizingly low in the sky for all of us in the temperate latitudes here in the north. So I first got into the southern sky in 1983 when I went to see the great long 6.5-minute total solar eclipse in Indonesia. I went back in 84 and then went back to see Halley's Comet from the center of Australia in 86 and then 89. And then for 25 years didn't go back. And I think that has something to do with the fact that kids came along. And so for our 25th wedding anniversary back in 2014, Helen and I decided to go back down and remembered how much we loved it, went back in 2015. And then our daughter happens to have graduated last year, was in Australia, so we decided to go to Australia again in May of this year. Now, in the previous trips in 2014 and 2015, I had taken a small little Ioptron tracking mount. Sorry, Skywatcher. I've also got an Ioptron one. A tracking mount for camera lens astrophotography, and I was fairly pleased with the results. But this time I wanted to do something better. I wanted to take a small telescope, a Teleview 4-inch or 101 millimeter refractor, and so I needed a heavier mount. And I think those of you, again, who are on the RESC list will have seen some of my photos in the description of that. So we went in May. I bought a new mount, a small mount, back last fall, tested it out, tried it. And this is going to be the story of that trip. It was a 4-week trip through Australia. And it's going to be a little bit of a photographic tour. So you can turn the light off me and the camera off me, because the whole thing from now on is going to be photographs, a bunch of astrophotographs. But one of the things that, why do we do this, and what can we see from Canada from our latitude? Well, this is black and white, but this is the Milky Way, just apropos of what Chris was talking about, the summer triangle, which you can see here, Vega and Deneb and Altair, and the summer Milky Way from Cepheus on the left all the way down to Scutum, the great star clouds on the right. And, you know, there's an awful lot of great stuff that you can see. But this is the northern Milky Way. This one photographed from Algonquin Park, and we can see also a couple of, we can see here a satellite and here a meteor. And so this is fine, and this is great, and this is what we are used to in the northern hemisphere. But taking May, for example, and I'm using Dave Lane's ECU Earth-Centered Universe program, this is what we will see at about 4 in the morning and in May, and this was the time that we went. And we have the horizon here, of course, and the teapot of Sagittarius and Scorpius. The tail of Scorpius very, very low on the horizon. Back in May, Saturn and Mars. And here we have the plane of the galaxy. So this is the Milky Way running down. And this is what we can see here from our latitude with these familiar constellations that we have all grown up with. And there is the center of the galaxy again, fairly low on the horizon, the great bulge of the Milky Way, which we can see, but not all that well. And everything down there we can't see. And of course, conversely, if you're down there, you can't see what's up here, but I think that they in the south probably have a better deal. And so what is missing that we can't see from this latitude? Well, some constellations we're not really all that familiar with. You'll see some photographs of these, Ara, Norma, and Lupus. But more interestingly, and what I call the great 3 Cs of Centaurus and Crux, the Southern Cross there, and Carina, which are, I think, my 3 favorite constellations in the south. We also have Triangulum Australe, Tucana, which has 2 actually really interesting objects, and then Octans, which performs sort of the same function or is in the same position in the south as Ursa Minor is in the north, because that's where the south celestial pole is located, although it's much more difficult to work with. And then we have the small and large Magellanic Clouds, which are sort of detached parts of the Milky Way. They look like it, part of the local group in orbit around our Milky Way galaxy, and that you cannot see from our latitudes at all. And so if you want to see the Magellanic Clouds, you have to go south, which is what we do. So this was this particular trip. This was a little shorter than our others. As you can see, it was 4 weeks, and this was our trip. It was 8,400 kilometers. Usually when we're in Australia, we do a circle trip, and so it ends up being either 11 or 13,000 kilometers. But this one we started in Melbourne. We flew there instead of Sydney, and then finished at Darwin, and then flew back, left the car there, rented a car here, left it, well, it was actually an SUV for the equipment we had. And these are the various places that we went. Now, when you're planning a trip like this, if you're an astronomer or an astrophotographer, you always need to plan around new moon. And so my wife Helen always asks me, okay, so we're going to Australia, when's new moon? And she knows that when it's new moon, I don't want to be down here, and I sure don't want to be in Sydney. So at new moon, this is where I'm going to be. And what that means is you work backwards from the time of new moon and figure out when you got to fly to Melbourne so that you can get up there, doing a lot of things along the way, and you're going to see some of that. And so that's how I go about planning these trips. It's all centered on new moon. All right? And so one of the things that's really important, bearing in mind, of course, that it's the opposite side of the seasons, is I prepared this. So this is for every day and where we were going to be every day during the whole trip, and then what the phase of the moon was, new moon here when we got to Alice Springs, and then the start and the end of the dark sky. And by start and end, what I mean is, bearing in mind moon, when the moon rises in the evening or sets, and when astronomical twilight either starts or ends. And so for the local time, which was Central Australian Standard Time, because they don't change to daylight at all, these were the times of the start of the dark period and the end of the dark period, and then the amount of time I had from the end to the beginning. So as you can see, after full moon and getting to our last quarter, you have only 1 or 2 hours of 3 and 4 and so on. But when you get in around new moon, I was getting 9 and 10 hours of darkness per night. And that's when I wanted to do my work. A lot of the time in here, we were visiting wineries instead, as you will see. So one of the things for if you're doing any kind of serious astrophotography, and I pretend to do serious astrophotography, is you have to align your mount with the pole. In the northern hemisphere, it's really easy because you've got Polaris, a second magnitude star that's about 52 arc minutes, or a little less than 2 moon diameters, maybe 1.5 moon diameters away from the actual pole, and it's quite easy to align your telescope on the pole. In the southern hemisphere, there is no bright or even moderately bright star actually anywhere close to the South Pole, and it therefore is really quite tricky because the closest star is Sigma Octantis, which is a very faint star. And so what I did is, and I do this regularly now, is I prepared finder charts, again, using ECU, Earth Centered Universe, and starting off, as you can see down here in the lower right, a 40-degree field, because I wanted to find out and remind myself about where everything was and approximately where the South Pole was. And starting here using Alpha Centauri, which is Regal Centaurus now. The International Astronomical Union recently changed the official name. And then Triangulum Australis. These 3 stars I use at this time of year because they're really quite bright, it's really compact, and I can figure out exactly where I am. And from there, I can star hop over. And then, going in now to a 20-degree field, this is where the South Celestial Pole is. These are the 4 stars I use. And you see, they're all 5th magnitude stars. These are faint stars. And so you have to use a finder scope. But if you can use these other stars, 3.8, 3.9, star hopping over from Triangulum Australis, you can get over here pretty easily. And then you will quite easily see, even before twilight is finished, these 5th magnitude stars coming out. This is a very familiar shape to me now. I know exactly where it is. And then you get really close and you can see some of these stars, and you can get a very good polar alignment. And so I think on the first night in this trip, it took me 12 minutes to get a polar alignment, and then from then on it took me about 5 minutes each time. when you get up to Kakadu National Park, where you're at about latitude minus 20, this part of the sky is really low on the horizon, though, and so it makes it much more difficult. So this is absolutely, in my view, vital preparation if you're going to do any kind of serious astrophotography and don't want to shoot yourself when you're down there because you can't get a polar alignment. One of the things I do as well, depending on the time of year I'm going down, is just to figure out at the end of twilight, where are the things that I'm going to be interested in. And so here for Coober Pedy, which is where I was going to start my work in the outback of Australia, this is on May 11th when we were going to arrive there. The end of twilight, where is stuff? And so we have the Large Magellanic Cloud here. We can see Crux, Alpha Beta Centauri, Crux, and Carina here, not yet. And this is due south, by the way, so not yet at the highest point. And what this told me is, first of all, the Small Magellanic Cloud at this time of year is impossible to photograph. It's just too low. Okay, fine, I got it a couple of years ago. But this time, the Large Magellanic Cloud here is going to go down into, remembering this is the southern hemisphere, so everything appears to be rotating the other way. It's going to be going down toward the horizon. And what that meant is, at the end of twilight, it was going to be 35 degrees up and getting lower. So it had to be one of my first targets that I was going to shoot this time. And well, we'll see in the photographs whether that worked or not. So this, and as you can see from all of these clusters and so on, this is the Milky Way. And at this time, at the end of twilight, Scorpius and Sagittarius have not yet risen. And so that's going to be much later in the night, well, actually sort of early in the morning. And then in the morning, as astronomical twilight is starting, you see the Small Magellanic Cloud is a little bit, that's okay. If I wanted to, I could shoot that. And we have Scorpius, Sagittarius here, and now Crux is descending down the sky. And so this gives me an idea of what is available to photograph during this period of time. And it is actually one of my favorite times. So, how many people have heard of this? How many people have one? All right. How many people like it? All right. I've got 6 copies of this. I have one at the office. I have one in the kitchen. I got one in my office upstairs. I keep 2 in the car. And then I have one packed to go to Australia. It is absolutely the most useful thing that I use. And the nice thing is that, it's really cheap and you can get it from Sky Publishing. And so it really is really terrific and it is fantastic to use at the telescope. I've been using it now for years, various incarnations of it. And one of the things I did is I photographed some of the charts and then put it in Photoshop and put all of this stuff on. And then printed them into 8x11 glossies, put them in sleeves, and so I could take them right with the telescope there, 8.5x11 sheets, and I could see where everything was that I wanted to photograph. All of the Messier objects and so on. Obviously, this stuff is visible, although fairly low in the sky from here. And then going and then down into the tail of Scorpius, which is difficult to photograph here. And in the southern hemisphere, at about 3 in the morning, it was directly overhead. Which makes it just fantastic both to see and to photograph. And then we get into Alpha and Beta Centauri, Crux of Southern Cross. This is a really interesting hydrogen gas cloud here. And then moving over to the Eta Carina Nebula, which is one of my favorite objects in the entire sky. And so this is what I took with me, and it really made it easy. By now, I know where all the objects are. But, first night out, I have to remind myself, oh yeah, that's there, and that's there, and that's there, and so on. And so this is really, really helpful. And if you're doing astrophotography, you don't have all that many nights, and you want to know where everything is and be able to turn to the stuff really, really fast. So here we are, arriving at Melbourne Airport, and yeah, that's all the stuff we had for a month. And there is the telescope. Well, actually, that's the telescope mount. The telescope itself is in my wife's suitcase. And what I tell her, well, what she tells me is, my clothes are really small and light, so why don't you put the telescope in my bag and everything else. This one here is actually, that carried the counterweights down, but most of it is empty, and that's because we used it to bring wine back.
which we do every time. Okay, so we start off in Melbourne. I'm just going to give you just a really, really quick little travelogue, because if you're an astronomer, you are curious. And if you're curious, you like traveling. And if you like traveling, you like spending time in really great and interesting places. And so we started in Melbourne, where our daughter was. She, by the way, she'd been there working for a better part of a year, and gladly hooked up with us for 2.5 weeks, because we were going to show her our Australia, and places that she would never necessarily get to. So the Yarra River, which goes up about 40 kilometers up to the Yarra Valley, where great Australian Pinot Noir is grown, and it is just an absolutely beautiful city. And so we stayed there for a couple of days, and then headed off along the south coast of Australia, that some of you will be familiar with. How many people have been down there, the south coast, down to, okay, well, all right, a lot of people familiar with that then. The Great Ocean Road, the Port Campbell Coast, the 12 Apostles, well, there are actually only about 8 of them now, because a bunch have collapsed, but that's okay, they don't want to get rid of the name. And what's really amazing when you get down there, and so, well, let's, let's see. This really is one of our favorite beaches. And what's sobering is, you look out across there and you realize the next land is Antarctica. So it's a pretty great drive. And so those of you who put your hands up will be very familiar with this view, I think. Early one morning we were actually leaving the Port Campbell coast. That is exactly what it looked like. And there are the remaining apostles. And so this is one of the things that we really like a lot, and you can actually, if you travel in the outback particularly, you can see a lot of these in the wild. This one not so much. So we have this little guy being carried around, and this really is a lot of fun. There's some absolutely fantastic game parks there. This one actually was in the wild. And this is shot from about, I don't know, 50 meters distance with a very long telephoto lens. Beautiful parrots all through Australia. That's a galah. They pretend to be fierce. They look fierce, but they're not. They're just absolutely fantastic birds. The crimson rosella. This is down on the southern road. And they're really friendly and very curious. This actually quite amazed us when we first stopped there, I think 3 years ago. Anyway, they're looking for food and just sort of a nice conversation, and it's a lot of fun. This is a wild emu in the outback, right along the Stewart Highway. It's really amazing. Every time we drive past this area. On the 800 kilometers from Kurupidi up to Uluru, within 10 kilometers, exactly the same stretch of road on the same side, this is where we see emus. This time, however, I spot a flock of 20 of them. And so I've got some other photographs that I haven't yet done, but this is one of the big ones. Again, photographed from as close as I could get before they started running away. Seals on Kangaroo Island, down about 120 kilometers from Adelaide. One jumping out of the water. Luckily managed to be able to get that one. And then, now, this is really interesting. You could do, this is in the wild, by the way, you could do, as astrophotographers do, about 55 stacked frames of a koala, and it would not have moved. You could walk all the way around it in 18,600 years, a precession cycle, and it would not have moved. They're fantastic, but you can really take your time photographing this stuff. It ain't like a solar eclipse where you've got to be shooting. So that's one little guy that. He was at Kennett River, and I know where to look. And I managed to sort of spot him up in a little crook, and then showed a whole bunch of other people. And this is a wild dingo up in Kakadu National Park. This one actually is very scrawny. Most of them are really beautiful. They look like wolves, and but this one was kind of scrawny, and I think in a bad mood. And then again up in Kakadu, in the very north end, Kakadu National Park is one of the great wonders and treasures of the world. Asian water buffalo were introduced back in the 1800s by the British, and then they kind of lost interest when they left, and so they've been rampaging through the wetlands. And this is one of these fellas, and it's a real problem there. They've been trying to get rid of all sorts of feral animals. Anyway, so this is the kind of thing that you can see when A, the sky's cloudy, or B, there's a moon in the sky. Oh yes, and of course the crocodile, one of the fiercest animals in the world. Yeah, so you don't want to get too close, for sure, or at least not look too yummy to them. And north of Kurupiti, heading up about several hundred kilometers south of the red center. This is really what it looks like. The color, these are the colors. And one of my first observing sites was about 100 kilometers south of here, just sort of off the road. And you get a pretty good horizon. And of course, everybody will be familiar with Uluru, originally, or well, the European name being Ayers Rock. In the center of Australia, one of the great icons of Australia. I first climbed it in 1983, and I think this year was the third time we climbed it. Next year, on October 28th, I think, October 28th, 2019, will be the last day for climbing, and it will be closed for climbing forever. One of the things that I did years ago, back in 1986 when I went down to see Halley's Comet, is something most Aussies have never even heard of. I swam on top of Ayers Rock because it was in after a spring of real torrential rains, and the rains had stopped about 2 weeks before I arrived, but there were pools and the fissures on the top, and you could just walk up and go all over wherever you wanted to. Just looked around, there's no one there, just stripped off and went in swimming. So I swam on top of Ayers Rock. Anyway, so, you know, why don't we, well, yeah, just I guess one last thing. So here we are in the Barossa Valley with Stephen Henschke, one of the most famous winemakers in the world. Tasty and his private cellar, we're sort of friends with them. And, you know, we spend a fair amount of time there, again, before the moon gets into the right phase. So, into the sky. And so, setting up. And this was actually done just outside Alice Springs. So this is the gear that I took. The equatorial mount that I bought. I think this one is something like $1,400. You know, not super expensive, but a nice little mount, and I was fairly happy with it. This was a Teleview apochromatic refractor, which is a really nice photographic scope. I actually had to buy a power tank battery down there because I was thinking about taking one down and shipping it, and it would have cost $400 to ship it. So I just bought one down there for $300, but I couldn't get it back, so I had to leave it. This is so I decided for this one not to use a smartphone, Denis, and I think that not that the results would have been not as good. However, there we go. A Telrad finder. It doesn't have a regular finder scope because the focal length is fairly short, but it's a really nice photographic scope. And a really good ball head for putting the camera on with camera lenses. And then you've got the astrophotographer. And so this is the setup that I used. And you can see here, I think, the elevation above the horizon from Alice Springs of where the South Pole is. It's not actually all that high, which makes it a little bit of a challenge. But that's okay. And of course, when you're out, you hear all sorts of rustling and everything, and you just know there are animals all around you. But all you do is you hear them, and you just can't see them all. So we're going to start with the southern Milky Way, and I had certain things that I really wanted to photograph this time. And I did a lot of, any of you who follow my work know that I really like wide-angle work. And so we're going to start here with, as we can see, Southern Cross, the False Cross. Now, everybody's heard of the Southern Cross. The False Cross is located to the west of the Southern Cross, and it rises therefore earlier. In the southeast, it rises earlier. And bear in mind, of course, we are used to, in the northern hemisphere, if that's the south, we're used to the sky rotating this way, well, because of the direction we're looking in. But in the south, when you're looking toward the South Pole with all of this stuff, the sky is rotating in the other direction, and so everything is rising in the southeast and moving across. And so what you see first, and a lot of people think is the Southern Cross, is in fact the false cross. You probably can't pick it out there, but I'm going to show you in the next one. And so what we have, okay, there we have the false cross, which is larger than the Southern Cross, same general shape and kind of orientation, and you can see how it fools people. And I remember it fooled me first time decades ago, actually. And so this is just one of the great areas of the sky. And you can see that there is an awful lot of stuff here. The Southern Cross, very bright stars, except Delta Crucis, which is only 2.7. But these are all first magnitude stars. And so it's very, very prominent. It's a tiny little constellation here. It doesn't have to be bigger. It's got a lot of stuff here. And then we have, obviously, the great Eta Carinae Nebula, which I'll talk about later. And here we have the galactic equator. So you can see that the plane of the Milky Way goes right through this area, which is why you have these great star clouds. And they're just really beautiful. And obviously, when you get away from that, you have a fair number of stars down here, but not nearly as rich as in the Milky Way. And here, and this is very prominent, we have a great big foreground dark gas cloud, very large in size, which is called, not surprisingly, the coal sack. And it really looks like a big hole in the sky. And so you got the Southern Cross, crux, and then the coal sack side by side. And you can see these objects naked eye, although obviously you can't see the colors because of our eyes and the way they work. And then a very large open cluster, the Southern Pleiades. You'll see some close-ups of those. So this is an area of the sky that we never see from here and really is just absolutely gorgeous. And so moving over just a little bit now, what we have here again is the Southern Cross, and then Alpha and Beta Centauri, Hadar and Regal Centaurus. And Regal Centaurus is magnitude 0.0. So it's a very, very bright star, one of the brightest in the sky. And a huge star cloud here, which is very similar to M24, the great star cloud in the Scutum area. And then here are the Southern Pleiades. And then this little thing. It goes by the old ancient Greek moniker, the Dark Doodad. And this was first kind of noticed and described by Denis of Sky and Telescope when he did a photograph outside Alice Springs in 1986. He was there to see Halley's Comet, as I was. And he photographed this and noticed this sort of sinewy, dark cloud, and he just called it the Dark Doodad. Well, it's as good a name as any. And so you can see here, this is just really a terrific area of the sky from Centaurus here to Crux and Carina, one of my favorites. It's just so gorgeous. You spent a lot of time here. So now we have a close-up using a 200mm lens of Crux here, the 4 stars. You can see that Delta Crucis is a lot fainter, but these three are very obvious. And then the coal sack. There are obviously stars there, and foreground stars, but a lot of the background stars are completely hidden. And right in here, near Mimosa, this star is a really tight little open cluster called, not surprisingly, when you look at it through the telescope, the jewel box. It is just so gorgeous. And one of the things you can see as well here, very prominently here, are the different colors of the stars. They are very obvious in this view. Okay, and again, the galactic equator going all the way straight through here. Okay, so that is Crux. And here we go. This is taken through the telescope. That was a 200mm lens. This is taken through the telescope. And we have Mimosa here. And then the jewel box only about 1.5 degrees away or so, with a bunch of other objects, little open clusters as well. TR for Trumpler, who discovered or described that open cluster. All right, and then I point out the Southern Pleiades. This is actually really interesting. The Southern Pleiades have some bright stars as well, as you can see, and around the same size as the Northern Pleiades, not quite as bright, and without the blue reflection nebulosity that we have around M45, the Northern Pleiades in Taurus. And what's sometimes kind of overlooked because of the brightness of this is this really nice little rich cluster here. It's not as bright, but it's a really pretty cluster to see through the telescope. So I will do a photograph and then take it off and camera off and put the eyepiece in and take a look at these objects after I've photographed them. And then Regal Centaurus, again, one of the very brightest stars. This is a tricky photograph to make because the star is so bright, and how do I photograph it without having it overwhelm the entire frame? But there are all sorts of little large and small open clusters here. This one is really interesting, Pismus 19. You can see that there's a little bit of color there. This is a very distant open cluster, and as a result, it has to pass through a lot of gas, and the gas reddens the light, and that produces that orangey color. And so that is one of the keys, that this is a very distant open cluster, which is a very interesting thing to see. Of course, you can't see it with your eye because your eye can't see those colors, but the long exposure photographs show this up really well. Now, there's an astronomer by the name of Gum in the Southern Hemisphere some decades ago who did a survey of gas clouds in the southern sky. And these, most of you will know this, but some of you may not necessarily. These are actually true colors. We can't see them with our eye, but these are glowing clouds of ionized hydrogen gas, H2 regions. And they are ionized and caused to glow by hot young stars that are very close by or actually embedded in them. And you can see this throughout the entire area. There's an enormous Gum nebula, an enormous one. You can sort of see. Oh, sorry, got to go back. Yeah, okay. You can see all of this. There's sort of faint red nebulosity all around, and then big knots of larger discrete nebulosity there, and this is throughout the entire area of the southern sky. And again, my star atlas showed that there were these things, and I was hoping I'd be able to get something with these Gum objects, and I was, and so I was fairly pleased with that. I'm not going to pretend that these are the world's best astrophotos; they're not. But with a little amount and the time I had, this is what I was able to get. This is a much larger one. I should point out the constellation Vela, the old Latin pronunciation would be Vela. These are really interesting constellations. You have Carina and Puppis and Vela or Vela. These constellations all used to be one huge, large one in Greek mythology, Argonauts. That is the ship of the Argonauts. It was a huge constellation and kind of unwieldy. And so in modern times, it has been broken up into three separate constellations. Puppis, the stern or poop deck, Carina, the keel, and Vela or Vela, the sail, all parts of the ship. And so you can sort of bear in mind the Greek mythology as you're looking at these constellations. Okay, and again, the galactic equator, we get a lot of this stuff right through the plane of the Milky Way. This is one of my favorite ones in Centaurus. It has, it reminds me a lot of you will have seen photographs of the red nebulosity around the central star, Gamma Cygni, in the Northern Cross. And this reminds me an awful lot of that, both in color, extent, size, and so on. And this is one of the objects that I really wanted to try to be able to photograph this time around. And all of these now are higher magnification through the telescope. Generally about a dozen identical stacked images. And I just decided to throw an extra camera on a tripod while I was doing some other stuff and see the Milky Way then setting in the west with the large Magellanic Cloud. This would be about 11 o'clock. And so Crux and Centaurus are sort of off the screen to the top. And you can see the Milky Way then setting in the southwest. It's quite a pretty view. This is one of the objects that I really wanted to get. I had three main targets, and this one, Omega Centauri. Now, what kind of object is this? Sorry? Okay. So, until, I don't know, 20 years ago or so, it was considered to be a globular cluster, globular star cluster, and by far the brightest of all of them in the sky. The two brightest of these objects are invisible from our latitudes, and they're Omega Centauri and 47 Tucanae. They're in the far southern sky. And then we have, obviously, some bright ones in the north, M22 in Sagittarius that a lot of people are familiar with. I photographed it recently up in Algonquin Park. Is another very bright one. But these two, 47 Tuc and Omega Centauri, take the cake. However, it now really is generally considered that Omega Centauri is a small dwarf galaxy, the remnants of a dwarf galaxy that has had its outer stars stripped away by interaction with the Milky Way. And so we don't call it a globular cluster anymore, although if you go to Wikipedia and many other sources, for example, the Trump White House, you will get the false news, the fake news that it is, in fact, a globular cluster. Well, it's not. It is, so that's what it's considered. And I got to tell you, I did not know that until recently. Peter Jedicke, the London Center, a longtime member, as long as I've been a member, told me about that, and so I did some investigating and reading and found that out. Anyway, this is a tricky object to photograph and to get all of the outer extent while still showing resolution in the middle, and so this took a lot of work to get this. But I'm actually fairly pleased with the resolution, and it's huge. It's about the size of the full moon in the sky. And I really like that object. So if I come back with only one astrophoto, I would have considered it a success. And this is the one that I really wanted to get. Now, the other one that I wanted to get, and I'd photographed it before, is the Great Eta Carinae Nebula. This is a very, very interesting object, and at its very center is the star Eta Carinae. This is a fantastically interesting star because it's kind of a cataclysmic variable star. It undergoes periodically bursts that are unpredictable. It is not an eclipsing binary. It is not a Cepheid variable with a distinct period. And no one knows exactly what causes this, but in the 1800s and 1860s, it underwent an enormous explosion in brightness and became the second brightest star in the entire sky, after Sirius, and even brighter than Canopus, for a short period of time, and then sort of went up and down over the ensuing decades, faded below naked eye visibility, and has now come back in recent decades to around fifth magnitude. And so it's just a really fascinating star, and also is the engine that ionizes the hydrogen gas, and has produced this incredibly detailed, highly structured nebula, and all of this stuff. And it's important to realize that these dark lanes are not holes in the nebula. They're foreground dark gas clouds that hide the nebulosity behind, in exactly the same way as the Horsehead Nebula is a foreground dark cloud of gas that is silhouetted against the Zeta Orionis nebulosity behind it. And so it's kind of hard to visualize that and to think about that, because it just looks as though it's a hole in the nebula. Well, it's not. But this is really one of the great showpieces of the southern sky. And again, this is the color that the camera picks up. To put it another way, it is true color. And I'm going to, I've said this before, I think, at presentations that I've done here, and at the General Assembly in Calgary, I made this point again. And it's a point about photography, but it's a point about astrophotography. In general photography, what most decent general photographers want to do is to depict what they actually see with their eyes, what we consider to be reality, and to reproduce that for memory and all of that. In astrophotography, we have to appreciate that the human eye is a very bad detector of dim objects. And I'm not going to go into all the physiology of that, but it's fairly well known, and you can read up about that. And in particular, the human eye cannot see color at low light levels, and that is why, as twilight comes and so on, all the colorful objects seem simply to disappear. You can see the objects, but they just become gray tone, because the cones in our eyes are very light insensitive. They see color, but they're light insensitive, and they just shut down. So we can't actually see the colors. And so in most astronomical objects, we cannot see the colors with our eyes. Some of them we can. Bright stars are bright enough to trigger the cones, and so we can see the blue and the orange gold, for example, in the double star Albireo in Cygnus. We can see the shocking pink prominences on the edge of the sun during a total eclipse of the sun. We can see that because they're bright enough. We can see a little bit of the color in the moon, some of the blue and so on, but the moon is actually one of the darkest objects in the sky. It reflects only 18% of light that falls on it. It's very, very dark. And this is one area in which, however, the photographic film in the old days and the digital sensor now actually captures what is there and that our eyes can't see. And in a way, therefore, in astrophotography, it is an example of where the camera shows reality way better than the human eye can detect it. And so, people say, well, geez, these pictures are also colorful. That's not what we can see. That is true. And I acknowledge that. But that's what's actually there. And that is one of what I consider to be the advantages of astrophotography. You can see what is there. You can see it with your eye. But if you want to appreciate what is actually there, if that's what you want to get from the sky, that's why we all do astrophotography, in my view. At the beginning of the show, I showed you the Milky Way in gray tone. Well, that's more what you see. And then I brought up the color, which is what the camera detects that the eye can't see. Anyway, so this is one of the great objects that I just adore. And we actually went in May, partly because I knew that this would be perfectly placed in the sky. You get down to November, when we were there in 2014, and it's too low, and we just can't see it at all. So to wrap up fairly quickly, we talked about this earlier, the Magellanic Clouds, which we can't see from the northern hemisphere. And here, and this actually was done in November 2014. Here, just to give you an idea, because this kind of won't be familiar to you, here we have Orion. And we have, so Orion is here. We have the 3 belt stars and the Great Orion Nebula. And so off the screen directly to the right is due north, and this is due south, okay? So it's sort of tilted. And here we see the Rosette Nebula. And here we have Sirius. And so the line, the horizon line, what we can see from the northern hemisphere, kind of runs like this. And we can't see anything below it. And here we have, of course, the large Magellanic Cloud and the small Magellanic Cloud. And very close by, that's 47 Tucanae, which is a globular cluster. And now I would say is the brightest globular cluster in the sky. And so these objects are fairly close to each other. They are not in the plane of the Milky Way. They look like they're detached segments of the Milky Way. The large Magellanic Cloud is at about 160,000 light years away, and the small Magellanic Cloud at about 200,000 light years away. So they're really close, bearing in mind that the Milky Way has a diameter of about 100,000 light years. So they're really quite close, and no wonder they have been tidally distorted, and they are in orbit around the Milky Way because of the immense gravitational pull. And so here is a 200 millimeter lens photograph of those, again, from a couple of years ago. And the small Magellanic Cloud here, and we can see 47 Tucanae. And as you can see, it's so bright in the center that it just gets burned in with any kind of exposure, and it's hard to get both the outer stars and any detail in the inner part. But that's a small cloud. And then that was a couple of years ago. And then this one is what I really wanted to get this time, and it's the large cloud. And what we have here is the Great Tarantula Nebula. And this is one photograph that I really want to get as well. And I was actually very pleased that I was able to get the detail in the Tarantula Nebula and also get a lot of the bright features of the Large Magellanic Cloud. And so a lot of these in the Large Magellanic Cloud actually have their own NGC designations. So these, again, are clouds of glowing hydrogen gas, not in our galaxy, but in this very bright member of the local group of galaxies that contains about 20 galaxies very close around. The Andromeda Galaxy, M33, which are the 2 brightest and largest ones, and then these 2 other much closer members with a lot of open clusters, which are foreground objects, obviously very close to us. And so you get an awful lot of these. And I got to say, I was really quite astonished when I saw the frames when I got back to Toronto and started processing these and saw, wow, there is an awful lot of hydrogen alpha in this area. So that is the Large Magellanic Cloud, and I was kind of happy to get that. And then So then you wait for the Milky Way, the center of the big bulge should be straight overhead, and that's when you photograph it. And so this is the center of the Milky Way right overhead at 3 in the morning from Coober Pedy, South Australia. And we have here Antares. The horizon line from Canada would go approximately here, so we don't see any of this. And we have, of course, here the Lagoon Nebula M8, the Trifid M20, the Omega and Swan Nebulae there, various objects that we're all familiar with. The pipe, the dark pipe nebula, which is difficult to photograph well here, again, because it's so low, but it's very prominent when you see it from the south. And so this is the center of the galaxy right there, and of course the familiar star patterns, and we are familiar with those. And there's an awful lot of stuff here. We have the Eagle and Omega and Trifid and Lagoon, M28 and M22, the great bright globular cluster here. And then a whole bunch of these dark clouds. B is for Barnard, who investigated dark clouds. And so when you see the B, it is the great American astronomer Barnard. Colander is the CR, and so we have some of these as well. NGC for the New General Catalog, and IC, the Index Catalog, which is sort of the supplement. And then this great star cloud here, which is quite similar to the star cloud that you get in Scutum as well, that we can see. So that is the center of the galaxy taken with a wide angle lens. Then zooming in just a little bit more, we can see now the tail of Scorpius, and we can see some of these objects as well. And we can see that these objects are in Sagittarius. Then just across into Serpens Cauda, we have the Eagle and M22 as well. So again, a little bit zoomed in. This is one with a 200mm lens, you can get all 4 of these objects in, and they're really pretty. And they're great for star hopping too, bearing in mind that you just can't see the colors. And I like this one. So we have obviously the Lagoon Nebula, a great nebula with a fair amount of detail, and the Trifid that has 2 aspects to it. We have glowing hydrogen gas, which is the red emission nebula, and then the blue reflection nebula, light reflected off the nebula rather than gas that has been ionized and glows by itself. And it's one of the few objects in the sky that displays that, but the blue is a lot fainter than the red. So I was fairly happy to get this. And one of the things that we don't see all that often is that with the lagoon, there's a lot of nebulosity all around here. It's not just sort of this central area. And this is really interesting as well, kind of a serpentine dark cloud of gas that surrounds it. And then the tail of Scorpius. This is about as low as we can get. The horizon's right down here, and it's really hard to see well. But when it's overhead, it's a lot easier to photograph. And one of our favorite objects, I think people who've seen this, is M7. It's a very bright open star cluster, and here it is. But what we don't see when it's low is how dense the star cloud is all around this, because it's right in the center, in the plane of the Milky Way. And when you're in the southern hemisphere, you can really see that really well. And then finally, we have Antares and the Rho Ophiuchi field, and you get an awful lot of interesting stuff there. Again, this is not the world's best photograph of this, but it's something that I wanted to try, and I think it's fairly pretty. And then a super wide angle view to finish up here, the center of the Milky Way. And here we have Alpha and Beta Centauri and the big bulge of the Milky Way. I think I may have said this before, and maybe it's the last comment that I'll make, and it's this. Students of the history of astronomy will be aware of the fact that when galaxies were observed with telescopes, starting in the 1700s and 1800s, there was a huge debate as to what exactly they were, how far away they were, and whether they were actually part of our Milky Way galaxy or far distant. A very great debate. And of course, they weren't called galaxies at all then. They were called nebulae. Nebulae from the Latin meaning cloud. So they looked like little bright clouds. Well, what exactly were they? And somebody will correct me, I'm sure I won't have the details right, but this led to the great great debate in 1920 between Curtis and Harlow Shapley as to, which was held, I believe it was in Washington, D.C., as to the nature of these things. One of them taking one side, part of the Milky Way, one taking the other side. No, they're really kind of replicas of our Milky Way galaxy, and they're very, very far away. Well, ultimately it was obviously determined, but only when Cepheid variables were discovered as the sort of distance marking stick that they were in fact external galaxies. And I read a long time ago, and this just makes a lot of sense to me. When you look at galaxies through external galaxies through a telescope, M31, for example, probably the best example of that. You see it's tilted about 22 degrees to our line of sight, but it's got a great big central ball. And the argument that was made is, all of the astronomers were Northern Hemisphere astronomers back then, and so they were doing all of this figuring out and all of that, and they couldn't see our Milky Way actually all that well from the north because the center of it, is really, really, really far south. Whereas when you are in the southern hemisphere and it's straight overhead, as I was in May, you can see the thinness of the Milky Way in the east expanding into this huge globular sort of ball and then thinning down as well. You look at it, say, my God, that's exactly what I see when I look at M31. And if the Milky Way had been visible in that way to Northern Hemisphere astronomers when this debate was going on, they would have seen that we are in the middle of what they're looking at when they were looking at all these other galaxies. And it would have been realized probably a lot earlier, maybe a century earlier, that in fact the galaxies are external and not part of our Milky Way. And so that's one of the things I think about when I'm down there, and I think about the history of this great debate and how Northern Hemisphere centric we are. And so it's an interesting thing to ponder while you're waiting for everything to get high enough to photograph. So there we have the galactic center again and our familiar star patterns. This is the horizon from our latitude. And so I will finish this way. Paul, I think I've probably taken more than my allotted time, and I don't know whether there are any time for questions, maybe not, but we'll leave it there.
Let's take a couple of questions.
If there are any.
I'm sure there will be some questions. Yes.
How long are your exposures?
That's a very good question. How long do you think they are? Every one of those photographs, every one of them was made, and they're all stacked, but every one was made with a 1 minute exposure. Every single one. Now, the Nikon D810A is a very good camera. It's a dedicated astro camera, as I'm sure you know. And I'm pretty careful with what with how I shoot them, but that's what they are. All of them. And so that's why I'm able to get what I get and as much as I'm able to get. And again, I do not pretend that these are the greatest astrophotos. There are a lot of RASC astrophotographers, Alan Dyer and Lynn Hilborn and so on, who produce, Lynn's got a permanent observatory. I got to lug my stuff up to Algonquin Park all the time. But it does show what you can do if you make the effort. And I appreciate that the equipment is expensive, but it shows what you can do with that kind of short exposure stuff. How many stacked frames? It depends on the object. For open star clusters where there's not an awful lot of detail as the stars, I will generally do 5 or 6. For detail, such as in M8, for example, I will always do at least 12 and sometimes maybe 16. Beyond that, the gain that you get is just not worth the effort. You just don't get any gain. And so that is the number that I will generally do. And using dark frames and so on, if I'm doing a stack of 12 on one object, got to multiply it by 2. So 12 objects, 1 minute each, 12 minutes times 224. So half an hour, in total of about half an hour's work, I can get all the subframes I need to put together an image such as the one you saw for the Triffid and the Lagoon. Half an hour for one image.
How far away were you actually from the dingo and the alligator?
Ah,
or the crocodile. Just curious. They were great shots.
I'm going to say about 15 meters for the crocodile. They're crocodiles. 15 meters. We're on a boat, and I made sure it had a bloody fast motor. Well, no, you couldn't. But I use a 400 millimeter lens for all of that photography. Yeah, so 20 meters. It was again. It was on a boat because it was in Kakadu Park. Yeah. Okay, we done? Oh, sorry. Not for the dingo. Yeah. No, I don't use filters ever. No. One more.
Great, Michael. What focal length of lens do you use for an extreme?
Well, I actually didn't take my 15 millimeter ultra wide one this time. The widest I used was 24 millimeters, which is really nice, or 35, but 24 gives you really nice view. And I also use, for those of you who follow me, I use the Sigma Art lenses, and the Sigma lenses, they're fixed focal lengths. One is a 15, one's a 24, and they are incredibly sharp. But the important thing is, and I'll finish with this comment, and I've said this many times before, these lenses are f1.4 or f2 lenses. You never, ever shoot with them wide open. So the Sigma lens, which is a superb lens, Terry Dickinson recommended it to me years ago, just when it came out, and I got one. It's an f1.4 lens. I always stop it down to f4. Well, that quadruples or quintuples the time I need to get the photograph. But what does it mean? The stars are pinpoints all the way to the edge, and there's no vignetting. And most people ask me, how the hell do you get stars that way? That's what I do. And because the CMOS chips now are so good, I'll boost the speed up to ISO 3200, even 4000. And you still get really good quality in wide-angle photos. Okay, that's it. Okay, so thank you again for having me.
Okay, so just to finish off some of the upcoming things over the next couple of weeks. Our next meeting is on the 26th of September, our speakers night, and we'll have Dr. Laura Parker from McMaster University speaking on the dark universe. And that'll be the first lecture meeting for the fall session. 4 weeks from now, we have our next Recreational Astronomy night. And do we have a speaker for the
Not yet. We're still looking.
Sky this month? Still looking. Okay. We have Dan Falk coming to talk about In the Footsteps of Nicholas Copernicus, and then Blake Nancrow talking about using the robotic Burke-Gaffney Observatory in Nova Scotia. Next solar observing session is Saturday, the 22nd of September in the Telescape area, and starting at about 10 o'clock in the morning. Usual thing is that Sean will make the announcement on the website and through the usual channels, courtesy of Peter Visma, on a go or no go, either Friday night or early Saturday morning. Our Dark Sky Star Party, next one will be on 8th to the 11th of October. City Star Party, 17th to 20th September, so next week. And again, go or no-go calls on our usual channels. Again, Dark Sky Star Party is at Long Sault Conservation Area, City Star Party at the Bayview Village Park. We do have an outreach event this coming Saturday at Millennium Square. Actually, both Friday night and Saturday are scheduled from 6 to 11. Again, we'll have a go or no-go announcement. Hopefully the weather will cooperate at least one of those nights. Especially Saturday night, which is also going to be the National Star Party for the celebration of the 150th anniversary of the RASC. So this time we'll be down at the back campus of the University of Toronto St. George campus. So that's the soccer fields opposite Trinity College. And the Dunlap Institute is setting up the area for us. There will be limited parking in the roadway from Hoskin Avenue towards Hart House. I think they've allotted 6 parking spots there for people to bring their telescopes in. And for the rest of us, please either take transit or park along the other streets. They are going to actually offer prizes to the visitors, so that'll be an interesting time there. We have an outreach event here on the evening of the 29th of September. Ontario Science Centre is going to have its first Nuit Blanche event. So it's an all-night event from 7 a.m. or 7 p.m. to 7 a.m., supposedly. Oh, we will stop at midnight. Okay. Mm-hmm. Okay. So Star Party finishes at midnight. Okay, great. But the actual display for Nuit Blanche is from 7 p.m. to 7 a.m. Okay. So we'll have more details on that on the website now that we've got that information. Okay, just a reminder that with the fall weather, we should have some good sky opportunities at the Carr Observatory, so it is available for you to book. And again, remember that you just need to log on to the website and use the reservation form online to request space. We do have the telescope loan program for those of you who are looking for instruments to try out before you actually slap the money down. We have a wide selection of equipment that you can try out, including an astrophotography kit. So again, we do have some of the managers that are here tonight. Mark, oh, just Mark tonight? Right. Okay, so if you are interested, please see him about arranging for a loan. And finally, we have the meeting after the meeting at the Granite Brewery at Eglinton and Mount Pleasant after the meeting ends. The other thing before I sign off is to just announce that there is a council meeting tomorrow night at York University at the Petrie Building, room 258, I believe it is. So if anyone is interested in coming to that, please see me after the meeting to find out about that. And are there any other announcements anybody wants to make? Okay, I guess Chris has something.
If anyone is interested, Jim Laframbois and I are hosting a public community star party tomorrow night in Thornhill Village. I'll put a post on the forum so people can see where that is if they're interested in coming.
Thank you, Chris. Oh, something from John Bodanowicz.
I have some Toronto Centre logo wear for sale after the meeting for the T-shirts. So if you're interested, just come down and see me. Thank you.
Okay. Okay, so that's it for tonight. Thank you for attending. Thank you to those of you who are online watching this at home in the comfort of your own home. Hopefully you enjoyed this evening, and we'll look forward to having you here at the Science Center or online at our next meeting in 2 weeks. Thanks again, and good night.